Howdy, howdy. Welcome to lesson 4. We are going to be working with our negative numbers and putting all of our prior knowledge together. So working with all of our equation solving skills as well as our knowledge of combining like terms, the distributive property, and negative numbers. One of the skills we're going to be adding to our tool belt today is learning how to check our work. Once we have the solution for x, how can we make sure it is the correct solution? We're going to follow a series of steps. Those steps are written out here. You're welcome to jot those down on your notes, but I will be running through them all with this equation right here. So we're going to start solving. The first thing we're going to do is use the distributive property. So we're going to take this -2 and distribute it in to our x minus 4. And with my t-diagram all set up, that distributes out to being -2x plus 8. Remember, negative times negative is positive, and all of that equals 12. My next step, I'm going to go ahead and combine my constants. So since I have a positive 8 right here, I'm going to subtract 8 from each side. Remember, we have to keep that equation balanced. That simplifies down to -2x equals 4. And so lastly, I can simplify my coefficient. Since my coefficient is -2, I'm going to divide both sides by -2. And positive 4 divided by a -2 means my x equals -2. Let's go ahead and do a check now. We want to make sure that we didn't make any mistakes. So we're going to take this x equals -2 and we're going to perform a check. How we're going to do that, our first step is we're going to return to our original equation. And then we will replace the variable with your solution. So we are saying that our solution is x equals -2. So I'm going to go to my original, not anything that you've simplified. You really want to start right with the original. So I'm going to say -2 groups of -2 minus 4 should equal 12. And then I'm just going to go ahead and solve that equation. So order of operations, can do my parentheses first. I have -2 groups of -6 should equal 12. And then I can distribute that and say -2 times -6 is a positive 12. And positive 12 does indeed equal 12, which tells me we did it correctly. So what you're looking for is if you get a true statement like 5 equals 5, or like what we have here, which is 12 equals 12, then you know that your solution is correct and you're done. If we had made a mistake and maybe we came up with something like -12 equals 12, that is not true, and we would need to go back through and check our work. But we came up with a true solution, 12 equals 12, so we're going to check it and we're done. One of the tricky things that comes up when we start working with negatives is we have to remember these invisible coefficients we have. Remember, our invisible coefficients are 1 and -1. And let's see how this plays out by just starting with solving this equation. And this equation actually has a invisible coefficient of -1. There's a secret -1 outside those parentheses. So when we distribute that in, we end up with -3 minus x equals 18. And then we can keep doing our normal algebra steps. Here we have a constant of -3, so we want to add 3 to both sides. And this is where we want to be a little bit careful because we know that -3 plus 3 is 0, but we have to remember that this right here, that is actually meaning that we have -1 sets of x. So we don't want to just ignore that negative sign. So once we made that 0, what we have is -x is equal to 21. And so what do we do now? Let's remember what our goal is of solving an equation. The goal of solving an equation is to find the value of one positive x. So we don't have that yet. What we have here is a variable with one of our invisible coefficients, and that invisible coefficient here is a -1. So we're not actually done solving. We still need to isolate that variable by dividing by -1. In doing this, -1 divided by -1 is a positive 1. We get that positive x we're looking for. Then we have 21 divided by -1 is a -21. And let's check our solution and see if we're correct. So our original equation, write it on out, replace that x with -21. And then PEMDAS, simplify that in parentheses, that turns into And then 3 plus negative 21 is negative 18 equals 18. And remember, there's that secret invisible coefficient, negative 1. So that's actually negative 1 times negative 18, which is a positive 18 equals 18. That is a true statement. We are done. Another tricky thing you're going to come across in these equations is when x is your numerator. And all you have to remember here is that there are a couple different ways we could write this x divided by negative 3 or x over negative 3. This is the same thing as saying negative 1/3 of an x, which is also the same thing as saying x divided by negative 3. These are all equivalent statements. So let's keep that in mind when we're solving. We set up my t-diagram. Get going on that first step where I want to make a 0 out of my constant. So I'm going to subtract 11 from each side. And I end up with this x over negative 3 is equal to negative 3. So since what's happening here is division, we always want to use an inverse operation. And since the inverse of division is multiplication, we can think of this as if this is actually negative 1/3 x, and we multiplied that by 3, which is 3 over 1, or let's do a negative 3, sorry. Then we're going to come up with negative 3 divided by negative 3, which just equals 1. And there's that positive 1 we're looking for. So when you see this x in your numerator, you know that x is being divided, and so what you want to do to undo it is we actually need to do a little bit of multiplication. So we're going to multiply by negative 3, multiply by negative 3. And if we do that, we get, it's this situation right here. So we end up with our one positive x that we want. And then negative 3 times negative 3 is a positive 9. And let's check it out for the check. That would be 9 over negative 3 plus 11 should equal 8. 9 divided by negative 3 is negative 3 plus 11 should equal 8. And that is indeed true, that 8 equals 8. So we call ourselves done. I want you to practice with this. Come on back and see how you did and check your work. So my value for x is negative 8.5. Gonna do my check. Should look like this. And let's remember when we subtract negatives, we are actually adding to our overall value. So this could also look like 0.25 plus 8.5, which does equal 8.75. But you just want to keep going until you have that proof that 8.75 equals 8.75. So you correctly balanced your equation and you are done. All right, try your journal problems. There's an answer key for every single problem. So if you are getting a different answer, just check over your work, or let me know how I can help. Thanks, you guys.